In the beginner algebra video, we focused on solving equations by keeping both sides equal, adding, subtracting, multiplying, and dividing to isolate the variable. In this video, we're going to take a step back and talk about something that comes before solving. Before we solve equations, we need to know how to rewrite expressions without changing their value. The goal isn't just to get answers, it's to make problems easier before we solve them. So in this video, we'll look at how order of operations controls what expressions actually mean, how to deal with variables in denominators by rewriting the expression, and how basic factoring can simplify an expression and save time. Along the way, I'll point out that there are often easy ways and hard ways to solve the same problem. And algebra is mostly about learning to recognize the easier ones. We're going to start with a quick little tip about the difference between an expression and an equation. So if we were to simply write out 3x plus 5, and not put any sort of equality, greater than or less than symbol, this is an expression. If we had gone 6x plus 3 equals 4, the fact that there is an equality sign makes it an equation because there's a statement that's being made about how the left-hand side looks like compared to the right-hand side. And for the first little bit, we're going to focus on expressions because there are ways to make expressions look easier to work with. And if we get comfortable with making expressions easier to work with, it'll make our lives a lot easier once we make the jump to equations themselves. Today, we're going to be kicking things up a notch, and we're going to be starting off with the order of operations. So in the basic algebra video, we had very simple equations that we could solve without really caring about which order we were doing things in. But there are some situations where it really matters. So for example, if I had 2 plus 2 times 3 versus 2 plus 2 times 3. Now these look a little bit different here. So what's going on? Well, when we're doing math, what we're really doing is we're trying to figure out how to move things from one side of an equation to another. So we need a way to actually specify what goes first, because there are some situations where we're going to want to do one step first, and there's other situations where we're going to want to do a second step first. So the brackets are there to tell us what we want to do first. So if we look at the brackets, we have to do these at the very beginning, because math is a language and the brackets are saying, hey, this is the most important thing. So we do whatever's in the brackets first. So in this case, it is 2 plus 2, which would be 4, times 3, which is equal to 12. All right. Now, if we look at the expression on the right-hand side, we still have 2 plus 2 times 3. And if we did the addition first, we would again have 4 times 3, and we would get the same answer. But if we did the 2 times 3 first, we would have 2 plus 2 times 3. All right, so that's going to be 2 plus 6. And look at that. We have ourselves this weird situation where even though these two expressions look very similar, we get completely different answers. All right, so we can see how the brackets actually make a very big difference. So if you see brackets, we have to respect them. They are the way that we signal to the world, this is what we want to do first. And then if we don't respect that, we'll get very different answers, as we saw down here. Now let's say that we didn't have brackets, and we did 2 plus 2 times 3, and we tried to do 2 plus 2 times 3 again, but we chose a willy-nilly order. So let's say that without the brackets, we still decided to do 2 plus 2 first. So we would have 4 times 3, which is equal to 12. And here we did the multiplication first. So we had a 2 times 3 first. So we have 2 plus 6 equals 8. Now in the blue case, there is no bracket like there was in the black case. So in the black case, we had very clear instructions. We want to do the addition first, then the multiplication. So we know that this answer down here is the correct one. So the question with blue becomes, how do we know which one is right? Because there is no brackets in the blue case. In the blue case, we have absolutely nothing to guide us in terms of brackets, but one of these problems is still correct and the other one is wrong. And in the blue case, the one that is correct is actually the one on the right-hand side. And the reason is there's a order in which we do things. All right, and the order is important because if we don't respect the order, then we'll have two mathematicians working on the same equation coming up with two very different answers. So we need to have a set of rules that we stick to in order to actually come up with a correct answer that we can all agree upon. So the order that we've decided upon as people who have studied math is listed on the left-hand side. So the brackets go first because that tells us if we want something to go first or not. So that's the most important. The next step down is exponents. Whenever you see an exponent, you got to do that one the very next step after the brackets. And then comes multiplication and division. Then comes addition and subtraction. Now, some people sometimes ask me, well, why do we do this? Well, part of the answer is so that we can avoid situations like the blue over here, where even though this operation looks the exact same, changing the order in which we do it has clearly changed the answer. The way I like to think of it is exponents are a fancy way of multiplying. So 3 to the 3 is 3 times 3 times 3. Multiplication, well, 3 times 3 times 3, you can see how multiplication and exponents are related to one another, but the multiplication is a less fancy way of doing multiplications because we're writing out the 3's over and over and over again. Whereas with the exponents, we just have one quick little 3 to the power 3, and we save ourselves writing out all of the multiplications. And now addition, we're going to have 3 plus 3 plus 3 plus 3 plus etc. So addition is really just a very basic multiplication, because multiplication I like to think of as a fancy addition. And then since multiplication is a fancy addition, exponents are fancy multiplications. So the order is really just an order of fanciness. So the very bottom bedrock is addition and subtraction, so that goes last. The next step up is multiplication, and then we have exponents. So we have to respect these at all times. All right, so down below we've got ourselves a couple of examples of why the order of operations is so important. So I've got two expressions that look almost identical with the exception of the brackets. And we're going to work through these problems together to see what is going on here. Now, if we remember, the brackets go first. So we've got a 3x plus a 5 in the brackets, and then it's being divided by 4. So we see here that absolutely everything inside of the brackets is being divided by 4. Whereas in the blue case, we have 3x plus 5 divided by 4. Now, because there are no brackets, the thing that we do first is going to be the division. So even though they look very similar, they're doing very different things. In the black case, the 4 is dividing everything on the left-hand side, whereas in the blue case, it's only one term of the left-hand side. So in case of black, I could say we have to do 3x plus 5 first, but the importance of the brackets here is really to let us know that the 4 is doing absolutely everything. It's dividing absolutely everything. So there's a couple of ways we could do this. We could try and bring the 4 into the brackets. So we would have 3x divided by 4 plus 5 divided by 4 equals 3. And remember, whenever we're doing algebra, we always want to put all of the x's on one side, everything else to the other, and go from there. So I've got an addition. If you remember from the basics video, addition is undone by subtraction. So I'm going to have 3x divided by 4 is equal to 3 minus 5 over 4. And then the left-hand side's almost done. We see that the x is being multiplied and divided. And in this case, it doesn't actually matter which order we do it in because everything on the left-hand side is multiplying and dividing itself. So divisions and multiplications are equal. I know that up above it said multiplication and then division, but that's just because we've got to list one before the other. But it really doesn't matter in this case because everything on the left-hand side is a multiplication or division. The same way that 2 times 3 is the same thing as 3 times 2, we're using the same logic over here. So for the sake of argument, let's say that we multiply by 4 on both sides. So we're going to have 3 times 4 minus 5 over 4 times 4. Notice that because the 4 is multiplying everything on the left, is dividing everything on the left-hand side, it has to be applied to everything on the right-hand side. So I multiplied the entirety of the left-hand side by 4. I have to multiply the entirety of the right-hand side by 4. And the reason I did it that way is because this will let us actually simplify to 12 minus 5, because we see we've got 5 times 4 divided by 4. 4's cancel out, and we've got ourselves a little equation, and then we can just do x is equal to 12 minus 5 divided by 4, and we can work out that fraction, and we've got an answer for x. Now, this is not actually the simplest way that we could have done this problem. I went out of my way to do it like this first to show you that even though there's lots of ways to do things algebra when solving an equation with algebra, there's usually a simplest way. And for me at least, doing it the simplest way / the quickest way with the least amount of work is the best way for me to do it. So if I wanted to solve 3x plus 5 in a bracket divided by 4 equals 3, I could stick to my guns and say, well, we have to do the bracket thing first, and that's why we did divisions by 4 everywhere. But instead, what I'm going to do is I'm going to go, okay, well, I've got brackets here. Everything's being divided by 4. Let me just get rid of the 4 right away. So I'm going to multiply both sides by 4, and I'm going to have 3x plus 5 is equal to 3 times 4. Now I see that the x is being added to, so I subtract both sides. And then finally, x is being multiplied by the 3 because it's 3x, 3 times x, so we get rid of multiplications with divisions. And look at that, 3 steps versus 5 steps. So it was almost double the work compared to the the left-hand side was almost double the work of the right-hand side. So by choosing selectively how we go about solving the equation, we can save ourselves quite a bit of work. So in this case, the brackets tell us what to do first, but they also tell us that this entire unit, since it's being added together first, is being divided by. So usually when I see a bracket term that's being divided, and I know that I want to get to something that's on the inside of the bracket, I'll get rid of everything outside the bracket because it's going to save us quite a bit of time. If you can compare the left-hand side and the right-hand side, you'll see what I'm talking about. If you can ahead of time know that you'll save some work, go with the saving of the work. Because if you're doing extra steps, that's just extra opportunities to make a simple mistake. And when we're stressed or tired or we're in a high stress environment, we're going to make silly mistakes. Now, let's go to the blue version here. Notice that the blue and the black are almost the same, but I have to respect the order of operations. So if I tried to solve blue the same way that I solved black, I would get the wrong answer. So with blue, there are no parentheses, so there is no the equations telling me I have to do this part first. Instead, I have to fall back to that convention. And remember, it's exponents first, then multiplication, division, then addition, subtraction. So I look at the blue, I want to get x by itself, and there's a bunch of stuff happening to it. Now, on the left-hand side, I see that there's a 3 multiplying the x, but usually it's always faster to make sure that x is by itself first and then go about solving. So right now, I'm going to get rid of this part first. So I've got 5 divided by 4. Now I could do some decimal points here to represent the division by punching into my calculator, but I hate decimal points with a passion. Fractions are usually easier to work with, and in general, they're a little bit more beautiful than having to deal with writing out really long decimal points, especially in a case where the fraction isn't nice. In this case it is, but there are some fractions that go on forever. And would you rather write out a fraction made up of 2 numbers or a decimal point with like 10 numbers, right? I'm all about saving ourselves some work. So what I'm going to do is I'm going to do 3x, and I'm just going to do the 5 divided by 4 to make it look like a fraction. Now I see that my x term is being added to. I get rid of that with a subtraction. And now I see I've got, okay, x is being multiplied. I get rid of that with a division. So I'm going to have 3 minus 5 over 4. Now notice that the 3 is multiplying everything on the left-hand side. So I'm dividing the entire left-hand side, which means that I have to divide the entire right-hand side to make it even. And we've got ourselves an answer that is correct. I'll leave it up to you guys to figure out what this looks like, because I've already posted a fractions video, and this is just good bonus practice for you guys. Now I'll let you pause the video for a second to try and get the right answer, and then underneath I'll write out what it's going to look like. There you go. And now we can see here, with a little bit of work, the 3 is dividing everything on the right hand side. So we're going to have 3 divided by 3 minus 5 over 4 divided by 3. Well, 3 divided by 3 is simply 1. 5 over 4 divided by 3 is 5/12. You can check my my fractions video if you are a little confused as to why. And then we simplify to x equals 7 over 12. So we see here the point of this whole thing was to show that brackets can change the actual value that we're going to get at the end. So we absolutely have to respect the brackets, because the brackets are mathematicians' way of telling us this has to go first, no matter what. We'll get very different answers if we ignore the brackets. And then even in the case that we do respect the brackets, we actually have the choice to go about solving the equation in whichever way we want, but there's usually one way that's more work than the other. The left-hand side, we brought the 4 in and then moved everything else over. On the right-hand side over here, we got rid of everything touching the bracket first, leaving the bracket by itself, and that saved us a lot of work. And usually that is what we want to do. Usually getting rid of the operation on the parentheses term itself is faster. All right, so far all of the examples we've seen in our videos have had the x, or the variable that we're trying to solve, upstairs or on the top. So what I mean is we've seen stuff like 3x divided by 4 plus 3 equals 5. We've seen things like 3x plus 4 equals 2. And these are fairly straightforward to work out. But one thing I've noticed is that sometimes students get stuck when we have the variable as the denominator. So sometimes we'll actually have equations that look like 3 divided by x plus 2 equals 4. So we notice that the difference between the top expressions and the bottom expression is that the x is stuck underneath. And it's really hard to work with things when they're stuck underneath, because there's no really easy way to work with it. So with these top expressions, well, 3x plus 4, we can move the 4 over, and then we've got a 3x, that's a multiplication, we can divide, it's easy to see what to do. Whereas in this bottom case, we could subtract 2 and get rid of it, but then the x is underneath. What the heck's going on? So one of the beautiful things about math is that it actually lets you get rid of stuff you don't like. So what do I mean? I want to make this expression right here look like one of the top ones. So what do I do? Well, if you ever have a variable that's stuck underneath and you think this division by my variable is gross, we identify the grossness, which is that right there, and we say, let's get rid of it. Well, we see that this is a division. So what we do is we get rid of divisions with multiplications. So I'm going to have 3 divided by x plus 2 equals 4, and I'm going to take the entire left-hand side, multiply by x, take the entire right-hand side, multiply by x. Because remember, whenever we're moving things around from one side of an equation to the other, what we're actually doing is we're operating on the entire left-hand side and the entire right-hand side, so we can keep everything nice and fair. So what's going to happen here? Well, we're going to have 3 divided by x multiplied by x plus 2 times x is equal to 4 times x. So if we look at the left-hand side again, 3 divided by x times x, this is all multiplication and division. So we can choose the order, because remember, 3 times 2 is 2 times 3. They're both 6. So in this case, I'm going to choose to do 3 times x divided by x first, plus 2x equals 4x. And then x divided by x is just 1, because anything divided by itself is just 1, unless we're dealing with zeros, but that's for another video. So we're going to have 3 times 1, we're going to have 3 plus 2x equals 4x. And look at that. If we compare this expression to the top expressions, we're once again in a position where the x's are all at the top. Not like this gross case right here, where we have an x stuck underneath, and it's really hard to work with numbers that are stuck underneath. I zoomed in a little bit there, sorry about that. So remember, in math, when you see something gross that you don't like, you can ask yourself, why is this gross? What is it doing? And then that'll give you the answer as to what to do. In our case, the grossness in this blue box came from us dividing by the thing that we want to solve by. So we multiply because we want to get rid of the division, remembering that we have to multiply everything on the left-hand side and the right-hand side. And then we'll get an expression like this one down here, where all of a sudden there's no more variables stuck underneath. And we know how to solve these very quickly. So I'll leave it for you guys to see that we're going to end up getting an answer that looks like x is equal to 3 over 2. On our last stop for intermediate algebra problems, we're going to discuss factoring. So up above, we've had a couple of different expressions where we have terms inside of brackets. So we've seen terms like 3x plus 2 divided by 4 is equal to 5, just for instance. And we've talked about how there's different ways to figure out how to get rid of everything so that we can have x by itself and everything else on the other side. We saw examples where we could divide absolutely everything on the middle, everything on the inside, and then work it out. And we've seen that it's usually faster to get rid of the term that's dividing or multiplying the entire bracket. That's usually faster. But the problem becomes, like, what are we doing? What's this we're dividing everything by? What's going on here? Well, it's a concept known as factoring. And the concept is if we have a repeated term, we can pull it out of a bracket. So for example, if I had 3x plus 3 is equal to 1, I see on the left-hand side that everything has a 3 inside of it, right? There's a 3 in front of the x, it's being added to by 3. So there's actually a way that we can pull things out of the bracket. We call it factoring. So I see that there's a 3 in front of everything. So what I do is I pull a 3 out. So what's going on is whenever you see a number in front of a bracket, what it's actually doing is it's multiplying everything inside of the bracket. So if I multiplied 3 by x, I'd get 3x. If I do 3 times 1, I'll get 3. And we can see that these two expressions are the exact same. Now, why do we want to do this? Well, because it's actually a little bit easier to solve things in this case. So for example, let's say I factored it in blue on the other side. There's a 3 everywhere. And let's compare like we did before. What happens when we do it two different ways? Well, if we didn't factor it out, we would go 3x plus 3 equals 1. The x is being added to, so I'm going to subtract, and I'm going to get 3x is equal to 1 minus 3. And then I see that the 3 is multiplying the x. We get rid of multiplications by division. X is equal to 1 minus 3 divided by 3. Now, if we did it the blue way, where the first thing we did was pull out the 3 because we realized there was a 3 everywhere, we would go, okay, there's a number multiplying a bracket. We saw before that it's easier to chip away at everything outside the bracket first, leaving the bracket intact. So then I would have 3 times whatever's in here, multiplication, so we use a division. Oops, my bad. Now we divided the entire left-hand side by 3, so we divide the entire right-hand side by 3. And boom, we're already done. We've only got the one fraction. It took us fewer steps. The fewer steps we do, the less chance there is of us making a mistake. So it's pretty useful to get used to factoring, because if you can recognize that there is a number in common inside of the bracket, we can always pull it out. And then if we can pull it out, we actually end up saving ourselves some work, because I would rather do 3 steps of work as opposed to 1, 2, 3, 4 steps of work. Now the jump from 3 to 4 doesn't sound very big, but as we start to work on harder equations, the difference starts to get bigger and bigger and bigger. Now let's give ourselves another example really quickly of how this factoring stuff works. So in this case, let's say we have 3x plus 9 is equal to 9. Now, if you're good at your multiplications tables, you'll know that the 9 is actually made up of 3s. So if you're good at multiplication, you'll know that this actually looks like 3x plus 3 times 3. Now, why do I go out of my way to write out 3 times 3? It's to show you guys that even though it looks like 2 separate numbers in black, if you know your multiplications tables, you'll go, aha, there's actually 2 3s multiplying each other inside of the 9. So what do? Well, we pull it out. So I see that there's a 3 everywhere in the blue, so I pull out a 3. Now, I know that there's only going to be an x left, because if I take away the 3, there's only an x. And now in the case of the 9, I'm getting rid of one of the 3's, which leaves me with 1 3 left. All right, so if I were to again multiply this 3 inside the bracket, I should get what's the original bracket. So if I do 3 times x, I get 3x, and then I'm adding it to a 3 times 3, which is 9. So you can always check your factoring work really quickly to make sure you didn't make a mistake. So in this case, aha, yep, we did everything right. By multiplying everything inside the bracket by 3, we get exactly what we had at the start. So then we're going to have x plus 3 is equal to 9 divided by 3. X is equal to, well, 9 divided by 3 is just 3. I see it's being added to, so I subtract. And look at that. We have ourselves a nice simple answer. So getting good at factoring requires you to have pretty good knowledge of your multiplications tables, and knowing your multiplications tables is going to pay off dividends. It's going to pay off huge later on. So the factoring is going to save you work by having you write out fewer steps, and then that is going to in fact make it easier for you to avoid making mistakes, because the fewer steps you make, the fewer mistakes you're likely to make. All right, so now we're at the point of the video that everyone loves. That's the extra fun bonus problems. I've written some out for you guys that cover some of the all of the terms that we've covered in this video so far. So for problem number 1, we've got optional, little hint, we can do some factoring. and that'll make the problem a little bit easier to solve. For problem number 2, I made it a little bit harder by including x's on both sides, remembering that with algebra we want to move all the x's to one side, everything else to the other. So just be careful with that. For number 3 and 4, what I'm really looking forward is did you understand the concept of following the orders of operation? So there's a mix of different orders of operations, and if you don't follow the order, you're going to end up getting a little stuck and getting the wrong answer. For problem number 3 and specifically, I'm touching on a little something that I kind of hinted at but didn't express explicitly, and that is that the brackets are first, but what happens if there's multiple things inside the bracket? Well, inside the bracket, we got to respect the order of operations. So a little hint here, we've got a multiplication and an addition. So you know what to do first. And then finally, for problems number 5 and 6, I've got brackets stuck underneath. Sorry, not brackets. I've got the variable stuck underneath. Remember how to get rid of those. And then 6 is going to be a little bit trickier because I've got x's stuck underneath on both sides. So just take a second, hit pause. I'll write out the correct answers underneath, and just give yourselves a chance to do it without my help. All right, as always, I've written the answers underneath in purple. For questions number 3 and 4, since there is no x to solve for, that's just the value of the entire expression, provided that you've done the orders of operations correctly. If you guys have any questions or you're confused as to what the answers are, please drop any questions in the comment section and I'll work them through with you guys down there. But other than that, I hope that you guys are a little bit more used to working with the order of operations, being brackets, exponents, multiplication, division, addition, subtraction. Hopefully now if you see those pesky variables as denominators, you'll have an idea as to how to get rid of it. Hint, get rid of it. And then finally, we've also covered factoring. So just remember, if you're good at your multiplications tables, you might be able to notice that terms inside the bracket have a common term. You can factor those out and you'll save yourselves a little work. Now that's everything for us today, and I hope that you guys have some fun and feel more confident going forward.